Hello and welcome to today's mini lecture. Today we are going to discuss and go work through some example problems of how to solve for pH. So the first thing I would like to do is look at the formulas that you are given in your chemistry resource packet. So you can either look in your chemistry resource packet and they're given in a line one after the other, or you can look in your notebook and I've got it set up like this. I set it up like this just for the simple fact of when I first look at it, I want to see how everything is connected. A lot of times I call this a wagon wheel, so you can go either direction on it. So first, let me just go through and show you the 5 or 6 formulas. So we have pH plus POH is equal to the 14, or is equal to 14. So we've already talked a little bit about the pH scale, and we decided that when a substance has hydrogen ions, they also have hydroxide ions. So because of that, they're going to have a pH, and because the pH scale is based on 14, if I take whatever the pH is and add it to the POH, it'll add up to be 14. Then I have the formula for pH, which is the negative log of and we said that the little brackets are concentration. So that's the hydrogen ion concentration. We also call that the hydronium concentration. And then over on this side we have the POH. The POH is the negative log of the OH ions. And then right under it, what happens is if I was to mathematically try to isolate the percent or the concentration of my hydrogen ions, then when I rewrote it, this is what it would look like. And I always go through and I say, guys, this isn't a math class, so I'm not going to sit there and manipulate all of this for you. I'm just going to simply say, if I try to get this by itself, hydrogen ion concentration by itself, I get 10 raised to the negative pH. And same thing for the OH, hydroxide ion concentration. It's going to be 10 raised to the negative POH. And finally, I can use the concentrations to determine the overall concentration of the pH scale, which is 1 times 10 to the 14th. So with that, let's go through and look at how we would go through and address different problems. So I'm just going to do these. I would like for you to follow along, write these down onto your paper, and then you're going to go back in and post them into your notebooks. So the first question says, what is the pH of 0.001 molarity, that's that capital M, that's concentration, of NaOH? First thing you have to recognize in this problem is I'm talking about NaOH, so I'm talking about a base. So if I'm talking about a base, can I solve pH directly? No, I have the concentration of my OH ions. So if I have that concentration of the OH ions, I can solve for the POH. This is where you have to stop and think about, and that's why I put it like this, so that you can use this to help you figure it out, where to start and where you're going to. So I am given a base, so I can't go directly to directly to pH. So I know that if I had the POH, I could find the pH. Knowing that, we set it up and we just simply say the POH is equal to the negative log of the concentration of my hydroxide ions, which is 0.001. So the POH is going to be the negative log, and guys, whenever you plug it in on your calculators, just put in the negative log of 0.001 and then hit enter. And the answer to that is a POH of 3. Now, I haven't quite solved my problem yet. All I've solved is for the POH. The problem says, what is the pH? Well, look, guys, I know that the pH is equal to the POH plus the POH is equal to 14. So I can go back in and say, all right, pH plus POH is equal to 14. pH is plus 3 equals 14. So therefore, my pH is equal to 11. So I went through and I showed you this with very simple numbers, 14 minus 3. Sometimes you have decimals, but it doesn't get any more difficult than that. All right, so on this problem, it was a two-step problem. The next problem I want to do is a one-step problem. So let's go back in and look at it. It says, what is the pH of 3.4 times 10 to the negative fifth molarity of HCl? So guys, we already talked about if it starts with an H, it means that it is an acid. So therefore, if I start with a concentration of an acid, I can go directly to my pH. We know that the formula is going to be pH is equal to the negative log of the concentration, 3.4 times 10 to the negative fifth. All right, so guys, I can solve this directly using this formula right here. The pH is equal to the negative log of my hydrogen ion concentration. So the key to this, and we've already discussed this, is going through and making sure that when I put this in, negative log of 3.4, I have to use my double E key, the exponential key. If I just say times 10 to the negative fifth, it's going to throw the answer off by one decimal. So I'm going to go back in and say second double E, and that is negative 5, and I end up getting 4.47. 4.47. So in yesterday's class, we were talking about acids and bases, and we were talking about the pH scale. We said that the pH scale is going to, acid is going to be less than 7. This is less than 7. It is an acid, so fundamentally that's correct. All right, let's keep going to number 3. It says, what is the pH if the pOH is 5? Hey guys, that's a gimme. That makes it real easy because I know that the pH plus the pOH is equal to 14. They gave me the pOH, so the pH plus 5 is equal to 14. And I like the math problems where it's nothing more than 14 minus 5. So I get a pH of 9. Now, look at that. Is that going to be an acid or a base? Definitely going to be a base. Always determine if it's an acid or a base based on the pH, not the pOH. Because a lot of times they'll give you this and they'll say, is this substance an acid or a base? And you'll look at it and go, 5, less than 7, it's an acid. No, that's the pOH. So you have to find the pH, then decide whether it's an acid or a base. If you do that, you'll get every single one of them correct. All right, still working on. It says, what is the pOH of 1.1 times 10 to the negative fifth molarity, that's the concentration, of HNO3? So guys, this is just like the very first problem I did, except they're asking me for the pOH and they gave me information about an acid. So I know that I can say the pH is equal to the negative log of, and I'm going to put 1.1 times 10 to the negative fifth. All right, so I'm using this formula right here. Once I have the pH, they ask me for the pOH. I can come back up, place it right there, just like I did in the first example problem, and solve for the pOH. So let's see what we get. I have to plug that into my calculator. All right, it says I need the negative log of 1.1 double E. I want to go exponential base, and then it says negative 5. And I end up with 4.96. 4.96. So my pH is 4.96. All right, so guys, this, again, I just double check as I go. Some just very common sense. It is an acid. The pH is below 7, so therefore it is working. So I did get the right answer. Guys, if you ever get the pH or the pOH to be like 42 or some astronomically large or small number, it's not the correct. You did something wrong in your mathematics. So I'm not through yet because it doesn't ask for the pH. It asks for the pOH. So I know, using this formula, if I know that the 4.96 plus the pOH is equal to 14, then my pOH must be 14 minus the 4.96. So I think that's 10.04, but I'm just going to make sure. It's 9.04. So let me go back in and put 9.04. And that's the pOH. All right, have one more problem. No different or anything. It's just I wanted to work a few problems for you. It says, what is my hydrogen ion concentration if the pOH is this? So I'm looking for that right there. So if I'm looking for the hydrogen ion concentration, then what do I need to know? The pH. Now somebody always says, well, Mr. Vance, could you use this formula and say I'm looking for this by knowing the concentration of this? Or if you had the concentration of that. And I said, you could, but they gave me the pOH. So I try to take what I consider the easiest route going through this because it's always easy to subtract from 14. So I'm going to say that my pH is equal to, that my pH plus my pOH is equal to 14. So that's going to be my pOH is 8.82. It'll take me just a second, and I'm going to have to put this into my calculator to make sure, and I get 8.82. And I get 5.18 for my answer, 5.18. Now, they didn't give me anything up here as far as like whether it's an acid or a base or anything else. So I can't really say, is this the right number? But I did my math, I did my subtraction, and this is what I got. So now I'm going to solve for my hydrogen ion concentration. All you have to do is say 10 raised to the negative pH. So my hydrogen ion concentration is 10 raised to the negative 5.18. You always hear me talk about not using the caret key, but guys, this is when you actually use the caret key. All you have to do is put 10 caret, which is raised to the, and make sure you get your negative in there, okay? Because it's the negative pH, negative 5.18, and I end up with an answer of 6.61 times 10 to the negative 6. And that's what the calculator gave me. So guys, I went through and I went over a lot of different examples. They're not really tough. It's just a little bit of practice. So the next activity that we're going to do after this one is literally going through and solving some of these problems and working them out. I hope this has been helpful.